Welcome everyone, and in this video I'll be showing you how to connect to a real database on the cloud, and also I'll be deploying my backend application to Heroku by the end. So let's get started. Let's get our database. I'm going to use Heroku for that. So go to the dashboard of Heroku, create your application. I have mine already. So I'll go to my resources. I'll find the add-ons, and to add Postgres or any kind of database, basically my preferred database is Postgres for any kind of projects, small to up until 1 million users. Okay, so this is the one that I'm gonna be using today, and which I recommend. But you can find any other database in the add-ons. But to add Postgres, just search for Heroku Postgres, select it, and it will be available in the add-ons list. So let's click on the Postgres add-on. We're going to need the credentials from this database in order to connect to it. Okay, so go to, well, this is the free tier. You see here the utilization that it allows you up until 10,000 rows, 20 parallel connections, 8 megabytes in data size, and as many tables as you wish, I guess. So the credentials, go to settings, database credentials, view credentials, and this is our credentials in order to connect to the database and see that it's up and running. Okay, so the tool that I'm going to be using to connect to the database is DataGrip, and this is quite a convenient tool to inspect databases. Okay, I believe it's not free, but you need to have a license for it. But if you do have a license, it's quite a nice tool. Okay, so once you have DataGrip started, in order to connect to the database, you need to click on the plus sign, add the data source, PostgreSQL, and in here basically copy and paste the credentials. Okay, so I already have a connection. I'm gonna go to the settings and show you that basically I've just copy and pasted the credentials that I got from the settings. Okay, and if you're doing this for the first time, you're going to have a link here to additionally download the PostgreSQL driver. So go ahead, click that, and once that is completed, you can go ahead and test the connection, and if everything is successful, you're going to get a green check mark in here. Okay, so this is what I have. Let's cancel and let's open and inspect the database. So it's, of course, it's an empty database, so it doesn't have any tables, but at least we've managed to connect to it successfully. Okay, so next let's go to the code and define actually components that are going to connect to our database. Okay, so let's switch to the code. So previously I showed the structure that is split into delivery, repository, and use case. So in the user repository, I have a file repository that defines code to read a file in order to get the user data. Okay, so in our case, we'd like to define a database repository with code that accesses our database and retrieves the user data from there, and has code to add a user, to insert a user into the database as well. So I already defined that file. It's under repository db user.js. Okay, so this is a user's Postgres repository corresponding to my Postgres database that I want to connect to. In the constructor, I get a database client. This database client will be initialized using the pg library in the server command. I'll be showing that a bit later. So I get the DB client, and with the DB client, I can do SQL queries to get the users, and an SQL query to insert the user. Okay, For details into these queries, please check the documentation of the PG library. Okay, so this is the library PG, simple as that. Okay, so the flow of the request, okay, just to recap, basically is that the delivery layer is going to get request, for example, to get the users, is going to delegate it to the use case. The use case is going to delegate it to the repository, and since we're plugging in a repository that requests data from the Postgres, the DB repository is going to get invoked, the get users. We're going to query the users from the database and return the users as an array. Okay, and similarly to add the user, the add user handler is going to get invoked, is going to pass the user to the service layer. The service layer, the use case is going to pass the user to the user repository, and in the user repository we can perform an insert statement to insert and create a new user in our database. Okay, so having said that, we can go into the server.js, and I can show you again that in order to replace our JSON repository with the Postgres repository is a matter of just commenting out the user JSON repository and initialize our user Postgres repository. Okay, and the user Postgres repository takes a DB client, which is we got from importing PG. This is a PG client, and it gets a DB config. DB config is passed to initialize the DB client. Of course, before starting the server, we want to wait until we could successfully connect to the database. So we do await DB client connect, and only then, if the connection is successful, then we proceed and start our server. Okay, so one little parenthesis on working with environmental variables. So of course, as you might have seen, that I'm getting all of the configuration variables from the environment, and when I'm deploying to Heroku, these variables, I'm going to get them from the Heroku dashboard. Okay, so all of these database configuration variables need to be specified in your Heroku app in the settings, in the config vars, right here. Okay, so whatever you specify in here, when you deploy, is going to be available in the code that process env and the name of the environment variable. Okay, so PG database is going to be process env PG database. Okay, so when deploying, we're going to be using these environmental variables, but for playing around locally, it's suggested to use a library called .env. Okay, so I'm specifying .env in my dependencies, and what it allows me is to have a .env file in my root of my project where I store these environmental variables with local configuration for connecting to a Postgres database, which can be running locally on my computer or some remote database even, but it's just for playing around, you know, so that you have one database, which is the production database, and another database which you connect to using env.env environmental variables. That is going to be the database for testing. Okay, and we can take a look at the package JSON that I have, for example, two commands to start my server. I have a command to start the server, and this one is going to get used in the deployment process, the just plain server.js, and I have one server local, which additionally gets the R parameter with the .env config, and basically with this R parameter, it tells the .env library to load the contents of .env into my local environment and make these environmental variables available to me locally when just playing around. Okay, so that was just a quick parenthesis on environmental variables, okay, and different workflows for production and local testing. So now, since we just, at this point, we just sort of assumed that we have a users table in our database. Of course, I didn't mention how we initialize our database and create tables, of course. So go to the repository. Okay, the script is just, the query is just to select and to insert. There's no script to create so far, okay? So regarding this, there is a mechanism called migrations. So with migrations, yeah, it's a nice sort of modern workflow to track database changes, okay? So imagine a scenario when you're running your application for about a year. You've done countless database updates to create tables, remove columns, add columns, rename columns. And at some point, you've broken your database and you want to go back and track what change actually broke the database. And one way to do that is basically check the logs, but that's quite painful no matter the database. Okay, so I'm talking about a scenario when you're running in production and you've been doing all of these in-flight modifications to the database via DataGrip or any kind of tool to basically operate a database, okay? And the only way to track these changes is to explore the logs of the database, which is quite painful because in the logs, not only you have the create and update and all of these alter table statements, but you also have statements corresponding to the requests that the users did. So every time the user updates a row or the user updates or queries some information, a log row is going to be added. So you might think that, well, it's quite easy, I'll just do a grep and just filter the logs, but in 1 year you might have accumulated terabytes of data, so that can be a bit challenging, okay? So the task is to track our database changes and modifications, and a nice way to do that is migrations, okay? So migrations, we have them, they are basically a list of SQL statements of changes to our database that are located, in my case, under DB migrations, okay? All of these migrations, they have a strict naming scheme. They have to start with 1, 2, 3, 4, 5. Basically, they have to be numbered so that we know the order, exact order in which we are executing them, okay? And the first migration usually is the statement that creates the tables, okay? After that, we can have that creates sort of the initial tables, okay, of the first version of the application. Now, later we can add other statements that alters the table, add columns, removes columns, even create extra tables, okay. But the first one is just that initializes, okay, the database. That's the first migration statement. Okay, so let me explain you the workflow, and let's imagine that, well, I'll show you that we're going to deploy this backend application. So when we initialize the deployment procedure, Heroku is going to execute npm start, basically, okay? Npm start, because I'm using yarn, I specified here that I'm going to do yarn migrate and yarn server. Well, you know what the yarn server does, because it basically executes the server command under the cmd folder. Okay, starts my backend application. But before we do that, we want to run our migrations, basically run all of these SQL statements. And we do that with this command, the yarn migrate, and migrate is defined down below. Basically, it's the same as server.js, except we're running the migrate.js command. And the migrate.js command is under the cmd folder. So what the migrate.js does, it makes use of the Postgres migrations dependency library, which I specified in the package JSON, Postgres migrations. And as I said, it basically runs all of these SQL statements, all of the migrations defined under DB migrations. Okay, so let me open migrate.js, takes a DB config, it needs to know where to connect to which database, where's our database located, okay, which server, which AWS server. Then we create a client, it's going to be a classic PG client, pass in the DB config, and then after we've connected successfully, we're going to invoke migrate, which we get from Postgres migration library. We pass in the client, and it needs to know the directory where our SQL statements are located. Okay, so we pass in the db/migrations. Right, so the first time, what's it going to do? It's going to run the migrations, all of them, in this case just one. It's going to create our table users, and it's going to via npm start, we're going to start our server once the migration was successfully completed. Okay, so I have all of this code committed already to my GitHub. So to trigger the deployment and to execute the migration, which will create my tables, I can go to my Heroku and retrigger the deployment. Okay, so I can go to deploy and deploy branch once again. Let's wait till that completes. Since I'm using Yarn, it's noticeably faster than npm. That might be because my dependencies were cached, maybe. Okay, so my app was successfully deployed. Okay, I can view my app. I get my hello on the root resource. Okay, if I go to users, just get an empty array because I don't have any users. Okay, but I can go now and inspect my tables and confirm that the migration has run successfully. Okay, so I'm just refreshing my database and I see here that I have my users table. Okay, but I additionally got the migrations table, and this migrations table is for the migrations library, basically to track which migrations we have already executed. Okay, so if next I'm going to go and add a new migration, call it to add column email to my user, SQL, add whatever, and in here I'm just going to be adding an alter table statement to add a column email to the users table. Okay, and I'm going to go and update my source code as well to accept in the repository my new parameter email as well when inserting a new user, and when querying as well we want to add the new parameter in here. So after I updated my code, added my migration, whenever I'm going to redeploy the backend server, because we have this migrations table, the library checks that table first, and it knows that we've already created the tables. Basically, we've created the users table. So now we don't need to run the first migration, we just run the second migration on top of that. And then we restart our server, which is has the updated code to handle the email column. And we've successfully basically completed a database and code migration. Okay, so this is how a nice way, to evolve your database schema. Okay, so this is migrations. One last thing about the Heroku deployment that I've done here. So the Heroku deployment, just to show it again, basically in order to deploy something to Heroku, you push your code to GitHub, okay, to a GitHub repository. I pushed my code to my GitHub repo. It can be private. So you go to deployment method, GitHub, okay. You connect in here, basically you connect to your GitHub account, and then you find the repo that you want to deploy, and then you basically connect to it. You enable here automatic deploys, and if you need to deploy manually, you just click on the deploy branch, okay? And the only requirement for Heroku is to have in the package JSON a script called start. Sometimes people like to call the command server, or something like that. So for Heroku, it's important to have the name start. This is the command that Heroku looks for when deploying your application, okay? And additionally, I had to add this part engines, okay, just to make sure. So in here, you're specifying the preferred versions of Node.js, NPM, and Yarn that you want Heroku to run your application with. Okay, so in my case, I wanted to run with Node 15 because I have a requirement on the server.js to have this explicit await statement, okay? By default, Heroku runs with version 12, I believe, and you have to wrap this await into an anonymous async function, okay? So I had a slight problem with that. That's why I added this requirement to run it with the latest version of Node.js, which supports basically straight up using await in my command. Right, so that basically concludes the, well, before concluding, let me actually show you how everything works, okay? So I've deployed my app, okay? We've seen that we can query the users. We don't get anything because we haven't added yet, but we can go ahead and add the user, okay? So I'll go to Postman. This is my URL. I can do a post request with the following body to just add a user. Okay, so I'm gonna add one, just add a couple of them. Okay, and I can do a GET request to get my users that I've just added. I can do that in the browser in the same way. So this is my backend deployed on Heroku, connecting to a cloud database also deployed on Heroku, which runs on AWS infrastructure. And yep, with that demoed, I think that basically concludes this tutorial. So thank you for staying with me and best of luck. Take care.